it looks like we are actually recording this time. This will be the third time I have recorded this video for you guys, but that's all right. It's going to work this time. And you guys are, especially those of you who are quarantined or virtual, this is a video that is going to go over a semester review that we're doing. And on this semester review, there's everything that we've done this semester. And what I need you to be able to do is show us what you can and cannot do. So what we have done is we designed this and we were going to give you an example of each type of problem. And then you're going to work the next two problems on your own. So each time after I do the example, you are to stop the video, do the next two problems. For example, when I do number one, you're going to look at that example. Then you're going to work number two and number three with your video paused. And then when you're ready, you're going to turn the video back on to go to problem number four. All right, let's see. I'm going to go in here because I need to reset something here. And we need to make sure that this is completely empty. We're going to reset that. All right, so now I'm going to log out and I'm going to go back in as if I am a student. All right, and we're going to do this review right here together. We have our little notepad right here. I think I'm going to stretch it a little bit more this time. And then we have this page right here that I'm going to make a little smaller so that we can see everything on the notepad part. Hope this doesn't make it too small for you. But this first part, what I said was we are going to look at an example of each type of problem, and then you're going to get to work two problems on your own. So we're going to start right here with question number one. Now it says, find the result graphically. Click and drag the arrows to represent each term. Type in the result. Well, -6. Well, if we're going negative, we're going to go to the left on the number line. And you can see in the circle that we went -6 over here. And now we're going to do +8. But we're going to start from right here. We're going to go all the way +8. And we ended up at the number 2. All right, we've done these before, but we figured you needed a little refresher. So we're going to submit that answer here. All right, and right here, you are going to do question number 2 and question number 3. And when you are ready, you're going to turn your video back on and meet us for question number 4. All right, question number 4. This time we have to find the result graphically in 3 different ways using what they call the commutative property of addition, which means it doesn't matter what order you add or subtract them in, you should get the same answer. If you are adding these different terms, it doesn't matter the order you do it in. So we're going to start right here. The first time, we're going to start with our first number here. We're going to go all the way down to -9. Then we're going to go +4. And then we're going to go +5. All right, and we end up at 0. If you mess up, you can always click start over. Now this time, we're going to start with the number in the middle. So we're going to go over to 4. Then we're going to go 1, 2, 3, 4, 5 more because we're still plus. And then we're going to go backwards or to the left, 9. And you can see the little numbers inside there. This time, we're going to start with our third number. We're going to start with that 5. So we're going to go all the way over to 5. Then we're going to loop back over here to the -9. So we're going to go -9. And there's our -9. And then we're going to go +4. And look, we ended up at 0, at 0, and at 0. We ended up at the same place all 3 times because commutative says it doesn't matter what order we do it in. And we are going to submit that answer. We are correct. And now it is your turn to work question 5 and question 6 on your own. Now, remember that you do it 3 different ways. If you mess up on one of yours, you can always click start over and it will let you start over. So pause the video, and when you're ready, turn it back on and meet us for question number 7. All right, question number 7. A scientist uses a submarine to study ocean life. She begins at sea level, which is an elevation of 0. She travels down 72.8 feet. Then she travels up 25.3 feet. And then she travels down again 68.7 feet. And we want to know how many feet she has to go back up to get to sea level. All right, so here's our line. All right. And we're going to say, since that's blue water, that's sea level right there. Okay? This is sea level or 0. Okay? Now, her submarine goes down 72.8 feet. Then from that same place, she goes up a little bit here, but she goes up 25.3 feet. And then from that point, she goes back down again 68.7 feet. All right. Now, so she went down, then she went up, and then she went back down. Now, a quick way that you can do this, we can use our calculator. But remember, now, she started at 0, and then she went down. So we have 72.8, and remember that is negative because she went down. All right, this plus minus changes it. All right, now she goes back up 25.3. All right, so she's still below sea level, and then she's going to go further down below sea level because now she's going to go 68.7 feet down. So when she's all said and done, she is at 116.2 feet below sea level. Now, if she is 116.2 feet below sea level, how many feet does she now have to ascend or go up to get back to sea level? Now, you can't put that negative sign in there because that means she's going to go further down. But we want her to come back up to sea level. So we're going to put 116.2 feet. All right, now you are going to work question 8 and question 9 on your own. And when you are done pausing the video and working question 8 and 9, you come back and you join us for question 10. All right, question number 10 says find the ratio of triangles to squares in the diagram below. Well, first of all, we're going to count our triangles because it's triangles to squares. We have 3 triangles, and we have, let's count our squares. We have 1, 2, 3, 4, 5, and 3 rows of 5. So 3 rows of 5 is 15. We're going to try that. They like that. Now, for every 1 triangle, there are how many squares? Well, here's a row right here. 1 triangle has 1, 2, 3, 4, 5 squares. All right. And then the simplified ratio is, here's your number, your first one, 1 triangle to 5 squares. Submit that answer. All right. And now you are going to do number 11 and number 12 on your own. When you are finished, turn the video back on because you're going to pause it, and you're going to go and meet us for question number 13. All right. Question number 13. It is a little bit different than what you did because this time it's asking the ratio of triangles to total shapes. It's not asking triangles to squares. It's asking triangles to total shapes. So we're going to count our triangles. There's 2. But when we count total shapes, it's not 4 because there's 4 squares. It's 1, 2, 3, 4, 5, 6 because there are 6 total shapes. All right, now for every 1 triangle, there are how many total shapes? Not squares, but total shapes. So for every triangle, there are 1, 2, 3 total shapes. Therefore, the simplified ratio is 1 triangle to 3 total shapes. All right, we're going to submit that. And then you are going to do question number 14 and question number 15 on your own. After you're done, start the video back up again and meet us for question number 16. All right, now we're getting to our ratios and proportions that we've been working on. A pancake recipe calls for 1 egg for every 5 cups of flour. How many cups of flour do you need for 6 eggs? All right, well, we have our little line here. All right, this is eggs. This is cups of flour. All right, so for every 1 egg, we have 5 cups of flour. And we want to know if we have 6 eggs, how many cups of flour do we have? Well, an easy way to do this, remember, if you are scaling up or going from a smaller number to a bigger number, which we are on here because we went from 1 to 6 and we want to know 5 to what, we're going to multiply. All right? All right, 1 times what gives you 6? Well, it's 1 times 6 that gives you 6. So if we do that there, we do that here. 5 times 6 gives us 30. All right, so we have, for 6 eggs, 30 cups of flour. Submit that. All right, there we go. Now you can see here how they solved it. Remember that on every problem, they have examples. And also, if you stretch this out, they have a help video. If you want to see how they explain it, that's fine. And here's an example right here. But you are going to work questions number 17 and 18 on your own. When you are done, you will join us again for question number 19. All right, question number 19. 10 pennies make a dime. How many pennies make 4 dimes? All right, well, we're going from 1 dime to 4 dimes, so we want to make sure that the smaller number is here and the 4 is here. And it says 10 pennies make a dime or 1 dime. So we're going to put a 10 right there. All right, now, again, on this one, we are making it bigger because we have 10 pennies, 1 dime. All right, we don't know how many pennies we need for 4 dimes. All right, so we're going bigger, so we're going to multiply. 1 times what gives you 4? It's 1 times 4 that gives you 4. So we have to do the same thing up here. 10 times 4. 10 times 4 gives us 40. So there are 40 pennies that make 4 dimes. All right, now you are going to complete question 20 and question 21 on your own. When you are done, start your video again, and we will do question number 22. All right, question 22. Serenity has limes and apricots in a ratio of 100 to 690. How many apricots does she have if she only has 10 limes? Okay, well, 10 limes are smaller than 100 limes. So we're going to put 10 right here, and we're going to put 100 right here. All right, and when she has 100 limes, she has 690 apricots. And what we want to know is how many apricots there are when she only has 10 limes. So this time, instead of getting bigger, we are going smaller. So let's do this. We don't know how many apricots she has right there, but we know that she has 10 limes. This is apricots, this is limes. All right. And then over here we have 690 when she has 100. Now, we're going to a smaller number, which means that we're going to divide. All right, so we're going to divide both of those. We have both of our numbers right here. So 100 divided by what gives you 10? So you could just divide 100 by 10. So 100 divided by 10 gives us 10. So we divided by 10 to get 10. Now, we're going to do the same thing here. We're going to divide by 10. 690 divided by 10. All right, so we have 690 over 10. A very easy way to divide by 10 is to just mark off these two zeros. So that gives us 69 apricots when she has 10 limes. We'll put 69 here, and it says Serenity has 69 apricots if she has 10 limes. There we go. And we're going to submit that. Now again, you are on your own for problem 23 and problem 24. All right, and then we will get back together for problem number 25 when you are ready. Okay, problem number 25. Scarlett bought 10 chicken wings for $24. How much would it cost for 17 wings? So we have 10 wings, and they cost 10 wings for $24. All right, so let's find out how much one wing is. Well, we would take our $24 and we would divide that by 10. All right, we can do this the long way. 10 will go into 22 times. So that's 20. Let's bring down our 4 and our 0 here. 10 will go into 40 4 times. So that's 40. And then let's bring down our zeros here. So $2.40 for one wing. Better be a tasty wing or a huge one. All right, so $2.40 for one wing. And we want to know how much are 17. Well, if we want to know that, we're going to take our $2.40 and we're going to multiply that times 17. And that's going to tell us how much that is. And we're going to take a shortcut right here. We're going to use 2.40. You can also multiply it out if you like, times 17. And that total cost is $40.80. All right, $40.80. And I am going to show you one other way that you can do this, because these are proportions, and that means that they have to be equal ratios. The ratios have to be equivalent. All right, let's minimize that for a moment. All right, so if you have 10 wings for $24, you want to know how much you're going to spend on 17 wings, but you don't know that number right there. So we're going to write this as a proportion or as an equation, because when we have equivalent ratios that make a proportion, you can cross multiply. Oops. Let's make this a little bit bigger again. All right, yeah, we can cross multiply. So we can say 10 times the number we don't know, and we're going to replace that with an x. 10x equals $24. And we're not going to put the dollars on there. We don't have to. Times 17. All right, so let's use our calculator, and we're going to say 24 times 17. That equals 408. So we have 10 times x equals 408. And all we have to remember is whenever we're multiplying, to get rid of it, we divide. So we're going to do the opposite. And we're going to do the opposite right here, the same thing. Our 10s go away. We're left with x. And then we're left with 408 divided by 10. Now, a very easy way to divide by 10 is to take that decimal and move it one place over. So we have x equals 40.8, which is, if we look over here, the same thing we came up with when we found the cost of 1 and then multiplied again. So let's submit our answer. All right, there we go. Why is it not submitting? Okay. All right, so I'm going to go back. That was question number 25, because what happens sometimes is it gets bogged down there. So 25 is done. There we go. Now it shows you that it was correct. All right, now you're going to complete number 26 and number 27 on your own. And that is as far as we're going to go on this first set. There are 2 other videos. The other one is 28 through 54, and the other one is 55 through 72. So let me go ahead and stop this recording. Hopefully it worked this time. I'm going to stop